Cisco Extended Detection and Response, custom bash scripts that I have written and used over the years to help with unique little situations that kind of pop up with customers when they're out deploying Cisco XDR solution. We're going to go over 3 of those today. But before we do, full disclosure, I am an employee of Cisco Corporation. However, the views and opinions expressed in these videos are my own and do not represent the official position, policy, or perspective of Cisco on any topic. And the scripts that I wrote were not created by any official dev group of Cisco. Those are just me, Bobisms that I wrote to try and help out on very niche situations. So there's 3 bash scripts I'm going to talk about here: netspeed.sh, netpps.sh, and devices.sh. NetSpeed is basically just your typical how many kilobits per second are coming into an interface, and net packets per second was how many packets were being sent per second. And I'm going to talk to you why I did 2 of them differently like that as I get into this a little more. Anyways, the last one there, devices.sh, that one is going to be run to see which exporters are sending to a particular PNM sensor or an ONA sensor. It actually goes in and it sees, who's sending the traffic, and it creates a text file with a list of all the sending exporter IP addresses. And remember, an exporter is somebody sending NetFlow to the sensor itself. Let's talk about netspeed.sh first. This one is pretty simple, just basically how many kilobits per second we're going to send to an interface. And you got to remember, inside that little PNM sensor, it's just an Ubuntu server, and it's all command line. So there's no nice little graph or anything to kind of take a look at it and see what's going on, and on the interface, how much traffic's coming in. There's some other things we could put on it to make it do that. Anyways, this one just seemed to work real good for me. But what it does is every second it updates with the amount of traffic that's going into an interface. And remember, since it's in kilobits per second, so if you have 800,000 of those bad boys showing up, that's about 800 megs. And on a 1 gig interface, what are we doing? We're pushing close to 80% of the advertised capacity of that interface on there, I guess is one good way to say it. So that's how I would use something like this. And I'm going to do a demo right now on that. So let's take a look at it on the command line so you can see what it is actually looking like. Here we are on the command line of one of my lab PNM sensors. And what we're going to do is we're going to change directory over to /usr /local /bin. And we're going to give an ls. You can see that it's empty in here right now. But what this is kind of, it's a place to put scripts and stuff that's in the path statement. If we do an echo path here, we'll see that right there in the path itself, usr /local /bin. So we'll be able to run these commands from anywhere and everybody can get to them. To download it, we're going to do a sudo wget and then enter the link to the raw output of the GitHub repository where I put this, and it downloads it real quick for us. And then we can do an ls -lh to see it. By default, it's giving us just read permissions. We need execute. So we're going to do a sudo chmod plus x and then netspeed.sh. And then when we do another ls-lh, you can see it's given us execute rights. All right, the next thing we're going to need to know is what interface we want to run this against. So in order to do that, we're going to type in IP space ADDR. Basically, it's the IP address command. And we're looking in here, and you can see I have two, ENS224 and ENS256. So let's stop here for a minute and talk about this. So ENS224 has an IP address. That's where I'm sending all my NetFlow to. ENS256, it doesn't. And what I'm doing here is I'm spanning over a virtual distributed switch inside of VMware to it. And both of these have the capacity to kind of be overwhelmed. Like in a large data center, if you're sending a lot of NetFlow from a whole bunch of exporters at the same time, remember an exporter is a router or switch or a firewall or something. If you have a whole bunch of them and you're sending everything on a recurring every 60 seconds, because if you ever go back and watch any of the NetFlow videos that I show you or download one of the NetFlow configs, I always set the timer to send every 60 seconds because with security related stuff, we want to get that information up into the XDR data lake as soon as we can. We don't want to wait around for 10 minutes or even 30 minutes that some of the default settings are for. So when it comes to security, we always recommend every 60 seconds you send that information. We've had a whole bunch of exporters sending it every 60 seconds. You can see that it can create quite the buzzsaw of information showing up at this little guy. In the case of the ENS256, where I'm spanning over a virtual distributed switch, where you can have a lot of devices connected to that. And so you have a lot of ESXi servers. Each ESXi server is hosting several virtual servers, and all those virtual servers are talking up a storm to each other. You can see how you can quickly span over, you span over several VLANs. Well, this little guy is just going to get overwhelmed as well. But NetSpeed and NetPPS, that's how we can kind of tell if we're pushing too much without having to do any really esoteric commands there or anything. Okay, so that's kind of what we're doing here. So we're going to do take a look at ENS224 first, and all you have to do is once we set it to be executable, we can just type in netspeed and then space ENS224. So let's go ahead and do that. And you can see what it's doing. It's telling me how much traffic's coming through it. Now, this is a lab, and I only have 3 devices actually sending any information to it. But, in a real environment, there's going to be a lot more traffic. But you can see how it's pretty bursty when it comes in. If we waited for the entire 60 seconds, you'll see this says nothing, nothing. And then all of a sudden, bam, a huge spike. All right, the other one, let's do the 25256. This is one where the virtual distributed switch is spanned over to the interface. And notice there's nothing ever transmitting, but there can be a lot receiving on this interface. So this is how you can kind of tell, are we just sending it too much for it to keep up with? And if we do that, it's going to drop packets. If it drops packets, we lose telemetry. We lose telemetry, we lose visibility into anything that may be going on in our environment. And we just do not want to do that. We need to see it all. So this can indicate that maybe we need to throw more resources at it, or maybe we need to add another interface, or most likely how I handled it was by adding a new PNM sensor to it to consume all that other information. All right, let's talk about the netpps shell script here. Let's clear this screen of the last demo we did. And yeah, let's go ahead and get started. We're going to sudo wget and then the link to it that you can find in the description for this video, just paste it in there. It will then download that directly from the GitHub repository. And we can do a quick ls-lh, and you can see netpps also doesn't have the execute right. So remember how we fix that with netspeed? We're going to do a sudo chmod plus x netpps.sh. And now when we do another ls-lh, you can see now we have execute rights. And we're going to be doing this against the interfaces also, just like we did with netspeed. We're going to have to indicate which one it is. So remember, if you're just doing this, we do the IP adder, and we have ENS224 and ENS256 down there. We don't need to sudo this. We just need to netpps.shell and then the interface. And this is packets per second that are coming in as opposed to just regular net speed that's coming in. So let's stop here and talk about this one as well. Why would we need to do something like that? When you send a whole bunch of traffic, it's kind of an interesting thing you can run into. And I ran into this once or twice, which is where this idea kind of came from, is that you can be sending a blast of so many packets that are small that the speed doesn't look like you're exceeding the speed, so it's hard to find, but we're creating so many interrupts from sending so many packets that the CPU on this little device could be starting to peg, even though it looks like you have a 1 gig interface, but it looks like you're only sending 200 megs a second or something like that. But we're just those are tons and tons and tons of really small packets. It's kind of another issue that can happen in a large environment, a large campus environment, or a large data center type of environment. Anyways, this should be able to kind of help you see it as well if you're looking at this and the packets per second is just going through the roof or something like that. I can kind of tell us that maybe that's the issue we're currently trying to address. So in this case, obviously it's a lab. I don't have that many packets per second, but we can also do this with the spanned one. So we're going to go back in ENS256 because this is where the problem most likely will be. And this is probably how we will run into that, especially, if we're spanning over 5 ESXi servers worth of virtual machines that are talking like crazy. You can see how we could easily be overwhelming the packets per second. And we might have to create a new little PNM sensor, some of the VLANs going to one, other VLANs going to another, something like that, so that they can possibly keep up with the amount of traffic in a large environment. And I'm talking about larger environments. I'm not talking a small office building or a small data center or something like that. It's usually in the really big ones where we run into something like this as a possibility. All right, this is the last one for this video, I promise. Devices.sh, devices.shell. This one's going to help us determine who's actually sending NetFlow telemetry. It's going to do a TCP dump, uh, and then we're going to do some grepping from that TCP dump to figure out who's the sending IP address on a certain UDP port. And then it takes that and prints, counts them all up, prints it out, and then even prints it to a text file. But because we're going to use TCP dump, we're going to have to use the sudo command with it so that the script actually has the rights to be able to see the stuff coming up on the interface that we need to be able to do with this sort of thing. So this is the one that you're actually going to have to use sudo for to actually make it work. So in this last use case, the devices.sh script, devices.shell, we're going to figure out who's actually sending NetFlow telemetry to us, what router switches and firewalls, because there's not really an easy way on the sensor itself to tell. And there is a place you can go inside XDR Analytics itself. If you go over here and you go to Investigate Roles and scroll down here to NetFlow Exporter, click on it. It will tell you which devices it thinks are exporters. And you can see I've got these two. One is this particular guy is a switch, and this particular guy is an ESXi server, but I actually have another device that's not being picked up. Um, through this method because it's just trying to watch some traffic and make some determinations based on the type of traffic it sees on what things are. So let's go over, how can I make this a little more accurate? And that's what this shell script is going to show us. Okay, let's actually open up this script, devices.sh, because you heard me say that it has to be run as sudo, and that could probably make a few people nervous. I get it. Um, so let's talk through it so you can see it's not really doing anything nefarious here. So on all my shell scripts, you can see there's a whole bunch of instructions and should be able to follow these and figure out how to use it. A couple of variables in here. I got output filed, exporters.txt. That's where everything is going to be sent to. Interface is set to any, though you could set that to an individual interface if you just wanted to see the exporter, say, sending to ENS224 or something like that. You can change that variable. You see ports 9995 and 9997. That's the ones that I'm going to be capturing I'm going to be capturing on everything, but I'm looking for traffic going to those particular ports or something like that. And this is kind of an interesting one because you can add more. You can go like or 9999. So add even more ports in here when you actually run that. We'll actually do some of this on the command line as well. Or you can make it go down all the way to just, one IP, or excuse me, one port UDP port number if that's what you're running your devices on, but this is something you can change. It's just going to take all the ports that you list there, just use the OR keyword. So um, something like that. Okay, and it's going to capture 10,000 of those packets. Now, sounds like a lot in a busy network. That might not be a lot. You're going to be sending a lot of telemetry. You can get to that 10,000 real quick. What you don't want to do, you don't want to make it so short that you know, we said, it comes out of there so fast that we never really get to see everything that should be sending. So you really want it to be able to, remember, if we're sending everything every 60 seconds from all our exporters, you want the script to be able to run at least a little bit longer than that 60 seconds. Now, I probably should have set this to run based on time, but I didn't. I did it based on packet count, and I don't feel like rewriting it. So you can change this, like I said 10,000 at first, but if you run it and it doesn't take the full minute, it's probably too short. Or if you run it and it's sitting there spinning after 5 minutes, probably too long. So try to do it, like 90 seconds or something like that. Should get everything to send at least once in that time frame. And look down here. This is all it does. It's going to run TCP dump for that interface. How many ports it's going to capture, those UDP ports that are referenced under ports. Errors go to devnull because I don't want to see them. It's going to look for the source IP address, writes it to a temp file for now, and then once it's complete, it takes all that and it puts it to an output file. That output file is named exporters, and then it's going to print, everything from it. These are the number that we sent. This is where we sent it. This is who sent it. You'll see how that looks. And then, of course, goes to that output file, which you can also change the name of. Obviously, it's just a variable. But you do have to run it as root. And if you forget to sudo it, hopefully it will tell you, hey, you did not run that. And that's just so that we can actually run the TCP dump command. Without that, in order to be able to run TCP dump properly, you have to use sudo in order to do it. So that's all it does. So it's not doing anything nefarious here. All right, let's go through that final walkthrough. Back on the command line, let's clear this, make a nice clean screen. And we are going to go ahead and download it, sudo wget, and then the link that is in the video description. It's also right here if you want to type it in. Downloads the file for us, give us an ls-lh, and you can see that we need to make this one executable the same way we did before. Sudo chmod devices. Oh, wait, we got to do +x, sudo chmod +x devices, and ls-lh. There it goes. Now it's executable. All right, let's clean the screen up one more time, and let's sudo nano, and we are going to go in and make some changes because 10,000 packets is way too many to wait for on my device. And also I got another port I'm going to add in the OR 9995, and what else do I want? I want 9997. Yep, I need 9997 and 9999. That's for where I'm sending the encrypted traffic to. Okay, and we're going to need to change the capture count here as well. Let's change that one to, and let's just do one interface. Let's do ENS 224. That's the one that's receiving telemetry, so I don't get the spam stuff. And let's just make this 100 packets. Like I said, it's just a lab, so I don't want to sit around here waiting all day long for this. All right, that looks okay. And save it. Control X, save, yes. And that's it. Sudo devices.sh. Having trouble typing today. Okay, capturing 100 packets. It's probably, oh, that was fast. Okay, that wasn't even the 90 seconds I told you to wait. Anyways, it found 3 of the exporters there. Remember, the other one showed 2, and I looked in the GUI. Well, here I found 3, and it also saved it to that exporters.txt file. If we ls here, you can see that file now exists. So we could use WinSCP or SCP it to a desktop and then email it to the network team and say, hey, we're only seeing 3 of these. We should be seeing 30 of these devices. Where's the other ones? Or we need to change some of these, whatever you need to do, however you want to use it. A lot of times I see this used for things like, if you're spreading the load or something across a couple of them and you need to find, where they're coming from, that sort of thing. So that's kind of what I could use something like this for. All right. Well, this video took way too long, but it's done now. And I am sorry it took so long, but boy, I even skipped a lot of stuff that I wanted to say. But thank you if you made it all the way through, and we do hope you find these useful.